Storing and querying massive data sets can be time-consuming and expensive without the right hardware and infrastructure. Now, BigQuery is an enterprise data warehouse that solves this problem by enabling super-fast SQL queries using the processing power of Google infrastructure. So you can simply move your data into BigQuery and let it handle the hard work. Now you can control access to both the projects and your data based on your business needs, such as giving others the ability to view and query your data. Hello everyone, this is Damon from Edureka, and I welcome you all to this session where I will be talking about Google BigQuery. So without any further ado, let's look at today's agenda. We'll begin by understanding why Google BigQuery is needed and what it is, and then we'll look at some of its key features and high-level architecture. Moving ahead, we'll get an overview of BigQuery storage as well as techniques of ingesting data into it. Furthermore, we will also look at different pricing models for BigQuery and try our hands on implementing it practically on Google Cloud Platform. Finally, we will then look at some of its use cases and the case study for it. First, let us understand why did Google release BigQuery and why will you use it instead of a more established solution. So Google BigQuery was established as a cloud-native data warehouse. It was built to address the need of data-driven organization in a cloud-first world. Now, BigQuery is a GCP serverless, highly scalable and cost-effective cloud data warehouse. Now, it provides both batch and streaming modes to load data. It also allows importing data directly from certain software as a service application using BigQuery Data Transfer Service. Second is ease of implementation. So building your own is expensive, time-consuming and difficult to scale. Now with BigQuery, you need to load data first and pay only for what you've used. Third is its speed. Now it processes billions of rows in seconds and handles real-time analysis of streaming data. Now that you have understood why we need BigQuery, let us now understand what actually is BigQuery. So BigQuery is a fully managed serverless data warehouse that enables scalable analysis over petabytes of data. Now it is a platform as a service that supports querying using ANSI SQL. It also has a built-in machine learning capabilities, so you can build and operationalize machine learning solution with simple SQL. You can easily and securely share insights within your organization and beyond as dataset queries, spreadsheets, and reports. BigQuery allows organization to capture and analyze data in real time using its powerful streaming injection capabilities so that your insights are always current, and it's free for up to 1 terabyte of data analyzed each month and 10 gigabytes of data stored. BigQuery service manages underlying software as well as infrastructure including scalability and high availability. Now let us look at some of the key features of BigQuery. Now first of all, it's serverless. So serverless data warehousing gives you the resources you need when you need them. With BigQuery, you can focus on your data and analysis rather than operating and sizing computing resources. So second is petabyte scale. BigQuery is fast and easy to use. On data of any size, with BigQuery you will get great performance on a data while knowing you can scale seamlessly to store and analyze petabytes more without having to buy more capacity. Now third is real-time analytics. So BigQuery's high-speed streaming injection API provides a powerful foundation for real-time analytics. Now BigQuery allows you to analyze what's happening now by making your latest business data immediately available for analysis. Fourth is flexible pricing models. So BigQuery enables you to choose the pricing model that best suits you. Now on-demand pricing lets you pay only for the storage and computation that you use. Now we have the flat rate pricing, which enables high volume users or enterprise to choose a stable monthly cost for analysis. Now fifth is automatic high availability. Now free data and compute replication in multiple locations means that your data is available for query even in the case of extreme failure modes. Now BigQuery transparently and automatically provides durable replicated storage and high availability with no extra charge and no additional setup. Sixth one is your data encryption and security. Now you have full control over who has access to the data stored in BigQuery. Now BigQuery makes it easy to maintain strong security with fine-grained identity and access management. And your data is always encrypted, addressed, and in transit. Seventh is BigQuery support a standard SQL dialects that is ANSI 2011 compliant. reducing the need for code rewrites and allowing you to take advantage of advanced SQL features. Now, BigQuery also provides free ODBC and JDBC drivers to ensure your current application can interact with BigQuery powerful engine. Let's now deep dive into BigQuery and have an architectural understanding of it. Under the hood, BigQuery employs a vast set of multi-tenant services driven by low-level Google infrastructure technologies like Dremel, Colossus, Jupyter, and Borg. It takes more than just a lot of hardware to make your query run fast. BigQuery requests are powered by the Dremel query engines, which orchestrate your query by breaking it up into pieces and reassembling the results. Now, Dremel turns your SQL query into an execution tree. Now, the leaf of the trees, it's called slots, and do the heavy lifting of reading the data from Colossus and doing any computation necessary. The branches of the trees are mixers, which perform the aggregation in between. Is shuffle, which takes advantage of Google's Jupyter network to move data extremely rapidly from one places to another. The mixers and slots are all run by Borg, which doles out hardware resources. Dremel dynamically appoints slots to query on an as needed basis, maintaining fairness among multiple users who are all querying at once. Now, a single user can get thousands of slots to run these queries. Dremel is widely used to add Google from search to ads, from YouTube to Gmail. So there is a great emphasis on continuously making Dremel better. BigQuery users get the benefit of continuous improvement in performance, durability, efficiency, and scalability without downtime and upgrades associated with traditional technologies. Also, BigQuery relies on Colossus, which is Google's latest generation distributed file system. Now, each Google data center has its own Colossus cluster, and each Colossus cluster has enough disks to get every BigQuery user thousands of dedicated disks at a time. Colossus also handles replication recovery and distributed management. Colossus is fast enough to allow BigQuery to provide similar performance to many in-memory databases, but leveraging much cheaper yet highly parallelized, scalable, durable, and performant infrastructure. BigQuery leverages the column input-output storage format and compression algorithm to store data in Colossus in the most optimal way for leading large amount of structured data. Colossus allows BigQuery user to scale to dozens of petabytes and storage seamlessly without paying the penalty of attaching much more expensive compute resources. Typically, with most traditional databases, to give you thousands of CPU cores dedicated to processing your task. BigQuery takes advantage of Borg, which is Google's large-scale cluster management system for clusters, runs on dozens of thousands of machines and hundreds of thousands of cores. So your query, which use 3300 CPUs, only use a fraction of the capacity reserved for BigQuery, and BigQuery capacity is only a fraction of the Borg cluster. Borg assigns server resources to jobs. Now, the job in this case is the driven cluster machines, crash power supplies, fails network, switch dies, and any rate of other problems can occur while running a large production data center. Borg's routes around it and the software layer is abstracted. At Google scale, thousands of servers will fail every single day, and Borg protect us from the failures. Say someone unplugs a rack in the data center in this middle of running your query, and you will never notice the difference beside obvious needs for resource coordination and compute resources. Big data workloads are often throttled by networking throughputs. Google Jupyter Network can deliver 1 petabit per second of total bisection bandwidth, allowing us to efficiently and quickly distribute large workloads. Now, Jupyter networking infrastructure might be in the single biggest differentiator in Google Cloud Platform. Now, it provides enough bandwidth to allow 1 lakh machines to communicate with any other machine at 10 GB. The network bandwidth needed to run our query, which uses less than 0.1% of the total capacity of the system. Now, this full duplex bandwidth means that locality within the cluster is not important if every machine can talk to every other machine at 10 GB per second. Racks don't matter. Traditional approaches to separation of storage and compute include keeping data in an object store like Google Cloud Storage or AWS S3 and loading the data on demand to virtual machines. Now, this approach is often more efficient than core tenant architectures like HDFS, but it's subject to local virtual machine and object storage throughput limits. Jupyter allows us to bypass this process entirely and read terabytes of data in seconds directly from storage for every SQL query. Now in the end, these low-level infrastructure components are combined with several dozen high-level technologies API and services like Bigtable, Spanner, and Stubby to make one transparent, powerful analytics database. BigQuery, the ultimate value of BigQuery is not in the fact that it gives you incredible computing scale, it's that you're able to leverage this scale for your everyday SQL queries without ever so much as thinking about the software, virtual machines, networks, and tests. Now, BigQuery is truly a serverless database, and BigQuery simplicity allows customers with dozens of petabytes to have nearly identical experience as it's free for our customers. Now that we have reviewed the high-level architecture of BigQuery, we now need to look at the BigQuery storage organization and format. Let's understand BigQuery resource model. Now, BigQuery organizes data tables into units called datasets. Now, these datasets are scoped to your GCP projects. Now, these multiple scopes project datasets and tables help you structure your information logically. Now, you can use multiple data cells to separate tables pertaining to different analytic domains, and you can use project level scoping to isolate datasets from each other according to your business needs. So in this, the first one are projects. So projects are root namespace for objects which contain multiple datasets, job access control, lists, and IAM roles. Now it also controls billing users and user privileges. Now second is dataset, which is a collection of related tables or views together with labels and description. It allows access control and dataset levels and define location of data that is multi-regional or regional. That is, if it is a multi-regional, it can have like US or European Union or any other multi-region. And if it is just regional, so it can be Asia Northeast. It specifically goes into the region, that's all. Now then there are tables, which are collections of columns and rows stored in managed storage and defined by a schema with strongly typed columns of values, and also allow access control at table label and column label. The next is views, so which are virtual tables defined by SQL query, and it allows access control at view level. And the last one is jobs. These are action runs by BigQuery on behalf like load data, export data, copy data, or query data jobs, which are executed asynchronously. The next in this we have is a storage management. Now let's review how BigQuery manages the storage that holds your data. Traditional relational databases like MySQL stores data row by row, which means record-oriented storage. This makes them good at transactional updates, and OLTP means online transaction processing use cases. Then we have is BigQuery storage. Now BigQuery on the other hand use columnar storage, where each column is stored in a separate file block. This makes BigQuery an ideal solution for OLAP, which means online analytical processing use cases. Now you can stream data easily to BigQuery tables and update or delete existing values. BigQuery support mutation without limits. Now mutation like insert, update, merge, or delete. BigQuery uses variation and advancement on columnar storage. Internally, BigQuery stores data in appropriate free columns format called capacitor, which has a number of benefits for data warehouse workload. BigQuery uses appropriate free format because the storage engine can evolve in tandem with a query engine, which takes advantage of deep knowledge of the data layout to optimize query execution. Each column in the table is stored in a separate file block, and all the columns are stored in a single capacitor file, which are compressed and encrypted on disk. Now BigQuery uses query access patterns to determine the optimal number of physical charts and how data is encoded. Now, the actual persistent layer is provided by Google Distributed File System, Colossus, where data is automatically compressed, encrypted, replicated, and distributed. Colossus ensures durability using ensure encoding to store redundant chunks of data on multiple physical disks. Now this is all accomplished without impacting the computing power available for your query. Now separating storage from compute allows you to scale to petabytes in storage seamlessly without requiring additional expensive compute resources. There are a number of other benefits of decoupling compute and storage. Now you can also take advantage of long-term storage. You can load data into BigQuery at no cost because BigQuery storage costs are based on the amount of data, like the first NGB is free each month and whether the storage is considered active or long-term. Now if you have a table or partition modified in the last 90 days, it is considered as active storage and incur a monthly charge for data storage at BigQuery storage rates. If you have a table or partition that is not modified for 90 consecutive days, it is considered long-term storage and the price of storage for that table automatically drops by 50% to the same cost as cloud storage near line. Now the discount is applied on per table per partition basis if you modify the data in the table. The 90 days counter then resets. Now best practice when optimizing costs is to keep your data in BigQuery rather than exporting your older data to another storage option, such as cloud storage. Take advantage of BigQuery long-term storage pricing. This means not having to delete old data or architecture or data archival process. Since the data remain in BigQuery, you can also query older data using the same interface at the same cost level with the same performance characteristic. Now let us learn how to load or ingest data into BigQuery and analyze them. There are multiple ways to load data into BigQuery, and depending on data sources, data format, load method, and use cases, such as first one as batch injection, second is streaming injection, third one is data transfer service. So the first one is batch ingestion. So batch ingestion involves loading large boundary data sets that don't have to be processed in real time. Now they are typically ingested at a specific regular frequency and all the data arrives at once or not at all. The industry data is then queried for creating reports or combined with other sources, including real-time. BigQuery batch loads jobs are free. You only pay for your storing and querying the data but not for loading the data. For batch use cases, cloud storage is the recommended place to land incoming data. It is a durable, high available and cost-effective object storage service. Now loading from cloud storage to BigQuery supports multiple file formats like CSV, JSON, Avro, and ORC. Now the second one is streaming ingestion. Now the streaming ingestion support use cases that requires analyzing high volumes of continuously arriving data with near real-time dashboards and queries. Tracking mobile app event is one example of its pattern. The app itself or the server supporting its backend could record user interaction to an event ingestion system such as Cloud Pop-ups and stream them into BigQuery using data pipeline tools such as Cloud Data Flow, or you can go serverless with Cloud Functions for low volume events. You can then analyze this data to determine overall trends such as area of high interactions or problems and monitor error condition in real time. Now, BigQuery streaming injections allow you to stream your data into BigQuery one record at a time by using the table data.insertAll method. The API allows uncoordinated insert from multiple producers. Now, industry data is immediately available to query from the streaming buffer within a few seconds of the first streaming insertion. It might take up to 90 minutes for data to be available for copy and export operation. However, one of the common patterns to ingest real-time data on Google Cloud Platform is to read messages from Cloud Pop subtopic using Cloud Data Flow pipeline that run in a streaming mode and writes to BigQuery tables. After the required processing is done, the best part with Cloud Data Flow pipeline is you can also use the same cloud for both streaming and batch processing. And Google will manage the work of starting, running, and stopping compute resources to process your pipeline in parallel. Now the best part with Cloud Data Flow pipeline is you can also use the same code for both streaming and batch processing. And Google will manage to work for this reference architecture, which you can see here, is like this covers use case in master trade. I hope you have understood till now, like cloud data, flowing cloud pop-ups, how and what is cloud storage, how does it works for making a pipeline through cloud data. So please note that you have option beyond Cloud Data Flow to stream data to BigQuery. For example, you can write streaming pipeline in Apache Spark and run on Hadoop cluster such as Cloud Data Proc using Apache Spark BigQuery connector. You can also call the streaming API in any client library to stream data into BigQuery. Now the third one is data transfer service. The BigQuery Data Transfer Service (GTS) is a fully managed service to ingest data from Google software as service apps such as Google Ads, external cloud storage provider such as Amazon S3, and transferring data from the data warehouse technologies such as Teradata and Amazon Redshift. GTS automates data movement into BigQuery on a scheduled and managed basis. Now, TTS can be used for data backflips to recover from any outage or gaps. Now, think of data transfer service as an effortless data delivery service to import data from application to BigQuery. Let's look at the pricing criteria and models of Google BigQuery. So, BigQuery pricing has two main components. So, the first is analysis pricing, which is the cost to process queries including SQL queries, user-defined function scripts, and certain data manipulation languages and data definition language statement that scan tables. Second is storage pricing, which is the cost to store data that you load into BigQuery. Each project that you create has a billing account attached to it, and any charges incurred by BigQuery jobs run in the projects are billed to the attached billing account. Now, the query storage charges are also billed to the attached billing account. You can view BigQuery costs and trends by using the Cloud Billing Reports page in the Cloud Console. So let's discuss the first one, that is analysis pricing model. BigQueries offer a choice of two pricing submodels for running queries under this model. So the first one is the on-demand pricing. With this pricing model, you are charged for the amount of bytes processed by each query. The first 1 terabyte of the query data processed per month is free. Second is flat rate pricing. Now, with this pricing model, you can purchase slots which are virtual CPUs. Now, when you buy slots, you are buying dedicated processing capacity that you can use to run queries. Slots are available in the following commitment plans, like Flex slots. Now, you can commit to an initial 60 seconds. Second is monthly plan. Now, you commit to an initial 30 days. Then there's an annual plan where you can commit to 365 days. With monthly and annual plans, you receive at a lower price in exchange for a longer term capacity commitment. Now, you can combine both models to fit your needs with the on-demand pricing, as you can pay for what you've used. However, your query is run using a shared tool of slots, so performance can vary. Now, with flat rate pricing, you purchase guaranteed capacity with a discounted price for a longer term commitment. Let's briefly understand the first one, that is on-demand analysis pricing. So by default, queries are built using the on-demand pricing model. With the on-demand pricing, BigQuery charges for the number of bytes processed. You are charged for the number of files processed, whether the data is stored in BigQuery or in an external data source such as Cloud Storage Drive or Cloud Bigtable. On-demand pricing is based solely on usage. So this is how the on-demand pricing structure looks like. You can see like queries on demands are there, then they are charged for $5 per TB. The first 1 TB per month is free, and if you pay in a currency other than like US dollars, the prices listed in your currency on cloud platform SKUs apply. Like here you can see the SKU is like how you need to choose your currency, and you can filter it by product SKU name or the SKU IDs or service region or service. Okay. Now let us discuss the second one briefly, that is flat pricing. Now, flat pricing, it is also available for high volume customers that prefer a stable monthly cost. Now, BigQuery offers flat rate pricing for customers who prefer a stable cost for queries rather than paying the on-demand price per terabytes of data processed. To enable flat rate pricing, use BigQuery reservation when you enroll in flat rate pricing. You purchase dedicated query processing capacity measured in BigQuery slots. Your queries consume the capacity and you are not billed for bytes processed. If your capacity demands exceed your committed capacity, BigQuery will queue up slots and you will not be charged additional fees. So there are flex slots which have like short-term commitments. So flex slots are special commitment types. So commitment duration is only 60 seconds. Now you can cancel flex slots anytime thereafter. You are charged only for the second your commitment was deployed. So flex slots are subject to capacity availability. Now when you attempt to purchase flex slots, success of this purchase is not guaranteed. However, once your commitment purchase is successful, your capacity is guaranteed until you cancel it. The following table shows the cost of the flex slot commitment. Here you can see like how its hourly cost. Now you can see like $4 for 100 slots and the monthly charges of $2,920. based on average of 730 hours per month. Then there are monthly flat rate commitments. Now following table shows the cost of your monthly slots commitment. You can see $2,000 is given for 100 slots. Then there's also annual flat rate commitment. Now the following table you can see here, which shows the cost of your annual slot commitment. You can see the monthly cost of $1,700 for our numbers of 100 slots. All this is for us and it's for multi-region. Let's move on to the second major pricing category, that is storage pricing. So storage pricing is the cost to store data that you load into BigQuery. Now you pay for active storage and long-term storage. So active storage includes any table or table partition that has been modified in the last 90 days. And long-term storage includes any table or table partition that has not been modified for 90 consecutive days. The price for storage for that table automatically drops by approximately 50%. Now there is no difference in performance, durability or availability between active and long-term storage. Here you can see like the first 10 GB of storage per month is free, and operation you can select like if it's active storage or long-term storage. Then pricing is given for like per GB pricing is given, like you can see for access to it is $0.02 per GB, and for long-term storage it is $0.010 per GB. So that's how you can see like for a long term how the price is safe, and in both of them you can see like the first 10 GB in each month is free. Now that you have a theoretical and architectural understanding of Google BigQuery service, let's now see a practical implementation by trying our hands-on running it on Google Cloud Platform. So you can just go to Google Cloud Platform console. I already have a Google Cloud Platform account here, as you can see here. I can simply just go to console. So you don't have any account, so you can go ahead and create one. It's a very good platform to have your account on. Also, you have to give your credit or debit card details. It will debit 2 rupees and it will also be refunded instantly, and you will get 300 free credits for 90 days. Now you can use that credit for your own demo. I'm showing you this demo. You can go ahead and use for that purpose also, and for using various other services on Google Cloud Platform. You can see the demo I'm going to show you doesn't require any cost. So let's start right ahead. We can go to BigQuery. Under BigQuery, this is the one. Just open it. Create from start. So you can just simply click here and create data set. You have to give it a name. So your project ID is this. You can even change it if you want, and your data ID. This I'll simply write as data demo underscore demo. Location, put it to default. Then we will simply click on create dataset. Dataset, you can see data demo here, and we simply create a table for that as well. For the dataset we need a, so we then create a table. So by clicking here, and simply you can see here again the project destination or your ID, then the name, and you can name your table as demo tb underscore BigQuery. So my table has been created. As you can see, this is a table, this is the data set, and this we have your data table. Now we can create a new project from here. See, you can see here my first project. So this is your first project. So what you need to do is you can add data. Now what we are going to do after you press click on add data. Now what we are going to do today, we are going to import a public data set named Stack Overflow. You can simply import your file from the local file, or you can use your Google Cloud Storage, or you can simply connect to an external data source. So in this demo, I'll be showing you how I'll be using the public data set. You can see the latest one is about the COVID-19 public data set. where you'll have all the information about the patients and how the cases are increasing and how the infected cases are increasing, or if they are going down, whatever the analytic is there regarding all the statistic and analytics, whatever is provided with the data of the COVID-19. All those are provided here in which state or which country, all those data are provided here. Okay, so but we are going with the Stack Overflow, so we can simply click here and type Stack Overflow. Then here it is. All the overview is given, like what is Stack Overflow. It is the largest online community for learners to learn, share their knowledge and advance their credits. We know all these things. Then there are sample, like here there are many examples of SQL queries. Run this query on these SQL queries as well. You can run these data. These are just a sample which are given. Now the questions posted and the answer and all these things are there. Now what we need to do is simply click on view dataset. It will take us to another BigQuery window, back to the query page. So yeah, so we are here now. The dataset has been imported. Stack Overflow. You can just click down. You can see here the table, and here is the table. So we have to query the table. First, now what we have to do is we have to give the flattened text. So we have to select the flattened text. So choose it from here, select tags, and then we can choose from a tag count, so drag underscore count. So select flatten underscore tags count, and then we have select. So we have to split the text tags from. Okay, let's put it all this limits, and we can remove it from here. Then select, split, then we put here the value as tags. Now from here we have to extract it. So like if there is any data column is given, so because we are finding from the last decade, right? So which point from the creation date, okay, there is in this creation date, so we have to extract from here. We want to extract from the recent date here. Now we can just choose year here, so where, then extract, where extract, then the year. We will have to join this, so put as cross join, and this we have the tags flatten score tags. Now you can group by flatten tags, so we'll say group by flatten tags, and then we have an order to tag account, so order flatten underscore tags, and then we have to order by tag count, say in descending order, so order by tag, and count will be in descending order, and we limit that to, since it's top 10, so limit that to 10. Select split, okay, this should be from cross join, unless. Okay, this should be for tags. Flatten 10 tags, cross. Okay, this seems fine. Then simply click on. Now it's done, so there's no more error. The process will take around 779.83 MB, which will run. So you simply click on run. So the variable process is showing. So we can just run the query now. You can see all the queries are here now, like all the technologies again. So you can see like the Python is topping the list. So then there is JavaScript second on the list. Until the last we have is Panda, which is around 35,684, and Python is around 2,226,689 or 20,000. So around Python is around 2,02,689 counts. Then you can see the JSON. Last digit, you can see their actions, like how many times they are searched. So we are successful here. Now we can see the jobs information is given. So what we can do is, when we just save this, we can simply save this, save query, click this, save. You can see it in JSON. You can see the tag counts here, 2 lakhs. You can even see that is in JSON, and you can see the Panda 35,684. Then we have here the execution details, how many time it took, like 673 milliseconds, and slot time consumed is 6 seconds, and the byte shuffle is for 5 MB. And you can see for each wait is 230 milliseconds, and the rows is like 13 lakhs till reduced to record reduced to 10th. Now if you can preview this, things a bit too small, just drag that upside so you can be able to see. You can see the input output from the sorting till the output of the view data. Go back to result. As you can see, put this also down. You can also share this table. As you can see here, you can also share this table, or you can copy the table and delete the table, or you can also export this table. You can also export, get the link and export the table, and you can also export it in Google Cloud Storage. Now all these things you can do, and then you can have like save view also. Now if you save this link, like it shows under view, like how the table is working. Under view, you can see here, you can see explore with sheets, explore with Looker Studio, and with lab notebooks. Save results. See, now you can share it through CSV, JSON's file, or a BigQuery table. So we'll save that. So we won't export this time. You can even schedule your query, so you can create a new scheduled query. But from this demo, I'll just leave it without creating a schedule. And the next thing you need to do is, if you go here more, you can format your query, or you can go to query settings. So query engines you can choose for what it's like cloud data, or a BigQuery engine. And also if you are like querying it, and if you have forgot to save it, you can save here. It can get saved in a template tables. That temporary table you can create it from here as well. You can see here all the things that have been there, like job priorities, destination tables. It can get saved in a template table. Now you can create it from here. Okay, now you can search it, all these things, like all these things that have been there, like the job priorities, then the system management. Now if you go to advanced option, see, as you can see, data is encrypted or not. And then we have the SQL dialects. So the location I have simply kept this as default with reference. Now all these things you can choose with the query settings. Just simply click on cancel on this. I hope you have understood it. Now you can see how everything is provided at the dashboard only. Every service doesn't take time. That's the thing about BigQuery, that it is very fast. Now let us understand some of the use cases for BigQuery. So the first one is migrating data warehouse to BigQuery. So you can solve for today analytics demands and seamlessly scale your business by moving to Google Cloud Smart and Data Warehouse Streamline. Also, you can streamline migrating path from Netezza or Oracle Redshift, Teradata or Snowflakes to BigQueries and accelerate your times to insight. The second use case is predictive analytics. So predictive analytics helps you predict future outcomes more accurately and discover opportunities in your business. So the Google Smart Analytics means BigQuery in Google is smart and its reference patterns are designed to reduce times to value for more common analytics use cases. With small codes and technical reference guides, you can learn how BigQuery and BigQuery machine learning can help you build an e-commerce recommendation system, but also predict customers and lifetime value and design propensity to purchase solutions. Also, you can bring any data into BigQuery. Make analytics easier by bringing together data from multiple sources in BigQuery for seamless analysis. Now you can upload files from local source, Google Drives or cloud storage. Bucket takes advantage of BigQuery data transfer service. Now data fusion plugins, or we can leverage on Google industry leading data integration partnership. Now you have ultimate flexibility in how you bring data into your data warehouse. So let's now see the case study for Google BigQuery. It's the final topic we are discussing, then we will wrap up. So you can see here, we have the Safari book online, which uses BigQuery to solve a few key challenges like building detailed business dashboards, to spot trends and manage abuse, improve sales teams' effectiveness through sales intelligence, and enable ad hoc inquiries to answer specific business questions. So all these things we will understand step by step. So what they did is they choose BigQuery over other technologies because of the speed of querying using a familiar SQL language and the lack of required maintenance. So Safari Books Online has a large and diverse customer base constantly searching for accessing a growing library of over 30,000 books and videos from an increasing array of desktops and mobile devices. These activity streams contain powerful knowledge which we can use to improve our services and increase profitability, locked up in the mountain of usage data trends such as the top users, top titles, and correcting the dots for sales inquiries. Safari usage data was much too massive to query online in its entirety with the previous tool. Said analysis could be done with the third-party web analytics tools such as the Home Nature, but those tools lack the ability to query and explore record levels data in real time. In addition, they didn't have a great background for developing visualization. SQL-like pairing had to be done on a smaller chunks of data and was labor and 10 seconds slow. Now they were impatient waiting for MySQL queries to finish and were often in doubts as to whether or not they should finish at all. Once you reach a database client timeout of 10 minutes, you are not in the realm of not being able to do ad hoc analysis. Answering often operational questions can be a time sensitive, so speed is important. Of course, it's very important, so Safari organization has actually played with Hadoop, but it proved to take a lot of resources to maintain. So they ended up putting it on the back burner for further projects. Then they learned about the Google BigQuery through a video from Google Inputs and Output determined it seems perfect for their use case. So they decided to try it out. So first step is you can see here in this diagram. This tells you how Safari gets the data into BigQuery. So no matter what database platform you use, the extract, transform, load setup can be challenging depending on your data sources. BigQuery is no exception. I will say then this diagram shows an overview of how the data flows through the landing and ETL server leading up to BigQuery. The usage data comes from Content Delivery Network in the CDN and Web Application Server logs. This data was packed into time-based batch chunks automatically copied into a landing directory. It needed some transformation to load into BigQuery in a format where we could get the most use out of it. Here are the basic steps Safari went through. So it got a list of all sources files that have previously loaded into BigQuery, then validate the list of sources files waiting to be loaded into BigQuery, then transform the files and copy the file into BigQuery cloud storage, then load the files into BigQuery and finally use the data once it is in BigQuery. So BigQuery proves to be a good platform for dashboard data and offers the capability of drilling into the data in the dashboard further with Big Data Query browser, and offer the capability of drilling into the data in the dashboard further with BigQuery browser based UI for adopt analysis. So here you can see is a dashboard used internally by Safari operation teams to monitor top user. If anything raises any questions, you can get more information about a user title and IP address by querying with the BigQuery browser tools. Now you can see here the dashboard Safari uses internally to keep an eye of the trending top titles. Again, if anything raises any questions in the dashboard, BigQuery can answer them for you. Now the data is fed to these dashboards by an intermediary scheduled jobs, which is executed via the script queries. Now BigQueries with the BigQuery line tools gets the result in JSON and then contacts some other web service to get more information which is not stored in BigQuery, such as the user data and the book thumbnails image. Then it's all matched up and presented in the dashboard. This is a good pattern as you won't want to query BigQuery every time the dashboard was loaded, as it will get expensive. It is best to do the analytics heavy lifting with a BigQuery, then store the result in something like a cheap lamp stacks of mass consumption. And then the second advantage that the Safari got through BigQuery is sales intelligence, which is another use case. BigQuery was great for covering Safari's web blogs for leads which came into their sales department. This allowed them to relate a leads to another accounts in the system or cause the level of interest someone may have in Safari by the number of previous book they had read in the past months on their sites. The lead is created in CRM system and the BigQuery asynchronously searches through its logs like this. So you can see this in query, you can see the query written. So the result is written quickly and reattached to the lead recorded, allowing Safari sales department to gain intelligence and contact the lead without having to wait around the information. This gives them a nice summary of the users, the IP address of the leads that has been done. While IP address are not perfectly identifiers, they are much better than nothing. You can see someone from this lead ID, you can see its usage history, then see how it is given. So you can see someone from the lead IP address has an anomalously view user ID 0 to 322 pages of a book, and some other users who have accounts with Safari already are active on that ID. Rather than use the BigQuery command line interface, this use case was better suited for server to server, or we say auth with an OAuth, which is like the authorization tool. Google even uses so with the Google API's client library for PHP. Now this enables them to create web services which match up data from different sources and return the result to the CRM. One of the sources is the BigQuery. One amazing testament to the speed of BigQuery is that it didn't have to implement the web service asynchronously. Now it returns the result from BigQuery within the timeout period of the web service that the CRM requests. Other use case of Safari which they took advantage of through using BigQuery is pure ad hoc querying, which aren't driven by dashboard but rather specific business questions. When Safari releases the Android app, it was easy to run a query on our usage data and so on Safari usage data to see the Android page group by day. Now in the Google BigQuery browser tools, it was easy to export query result as a CSV files and load them into Google spreadsheets to make charts. So you can see here how this show when this release their Android apps. This is the graph, and here's an example of looking at the top users by number searches during a particular hour of the day. There really is no limits to the kinds of insight you can gain from the investigation of data. From an ad hoc perspective, there's a huge sense of power being able to answer any question about your millions of rows and data in seconds. For example, you can find out if that strange traffic on your site is a foreign spam bot or a malicious user as recommended by Google. They divided the data up into years. You can see this in the table. Normally, this will be a bit of an inconvenience to have to do a union statement between the tables, but BigQuery have a nice shortcut for this. So you can give this shortcut, and what this will do is create a union between the tables. So they just stack on as many years back as they needed to go into the time shaded tables and unions, and then together, since they have made their schemas the same, At the end of each year, they archive of active tables and start a new one. This is the best of both worlds as it provides the accessibility of having all your data in one big table with the performance of having them separate as they grow. It will make sense to further share the data into monthly increment instead of yearly. Now the summary of this case study is Safari generated meaningful knowledge out of a massive amount of data in timely manner, which is a challenge for Safari books online. Like many businesses needed to solve, being able to keep on top of trends as they happen while you can still do something about them instead of month after the fact is very valuable. This leads to low abuse problems and top line revenue increases by gathering marketing intelligence on trending topics and collecting lead intelligence to close sales more effectively. So that was the summary of the case study. With this, we have come to the end of today's session of Google BigQuery. I hope you had a great time learning and understanding about it. And if you have any queries, please feel free to leave them down in the comment section. Until next time, thank you.